All right, so we're going to be talking about electron configuration, which is by far probably the trickiest part of chapter 3 of kind of the structure of an atom. Okay, so take a deep breath and here we go. All right, we talked about the Bohr structure of an atom, right? And like figuring out how many shells an atom will have, where those electrons are going to be. Now we're going to be even more precise with electron configuration. Okay, there's basically 3 different kind of pieces of this electron configuration that we're going to talk about. So there are shells, subshells, and orbitals. Okay, so these are kind of our 3 main parts to understand with electron configuration. Okay, so we'll just kind of start big and work smaller. All right, so we'll start with shells. This is kind of the easy part because you already hopefully have a basic understanding of electron shells. This is just going to be numbers 1 through 7. And if you're looking on your periodic table, right, shell 1, shell 2, this is by period on your periodic table, right, shell 4, 5, 6, 7. Okay, so you have 7 electron shells where those electrons are going to be. Shell 1 is going to be the smallest, and it's going to be the closest to the nucleus with the least amount of energy. So that's shell 1, and then shell 7 would obviously be the biggest, furthest away. I'm abbreviating, okay? So shell 1 would be the teeny tiniest one, right? Shell 1, which, you know, hopefully, again, shells we already kind of understand from Bohr structure, but shell 1 is going to have hydrogen and helium on it. Shell 2 is going to have all these guys, okay? All right, so this is the part that we hopefully already understand. Then, then we get into subshells. All right, so subshells are going to be letters, and the letters are S, P, D, and F, okay? And these are the different subshells, okay? So they're like shells within the shells themselves. So they're like specifically shaped shells. Why do we do that? Specifically shaped shells within the big shells. Okay, they are subshells. So, and I'll break this down a little bit better, a little bit more as we go along. Okay, so, okay, S, P, D, and F. There we go. So S is like a sphere. P is kind of like a, I don't know what to call this, like a dumbbell. D is kind of like a flower. And F is absolutely crazy. It's this, 3D, I don't even know if I can. And then you've got some going out in the back and up front. That's, I don't know what to even call it, crazy, okay? So there you go. There's your S, which is a sphere, right? Your P, which is kind of that blue dumbbell, okay? The D is like a flower kind of situation, 4 petals, and your F is that kind of crazy situation, okay? So these 4 letters, okay, these 4 subshells are within your big shells 1 through 7, okay? I'm gonna draw this on the next page to hopefully hammer that in, okay? And then you have orbitals, okay? So orbitals would be like your number of locations within each subshell that you can find electrons. Yeah, let's say number of locations of each subshell. I think that kind of boils it down, right? So your orbitals tell you kind of how many P subshells you're going to have. Okay, so do you have 1 of them? Do you have 5 of them? Do you have 3 of them? So this kind of gives you your number of subshells as your orbital, the location that you actually find your electrons, okay? And then important piece for an orbital, there's a max of 2 electrons per orbital. That's my dog in the background rolling over while he's napping. Okay. And you have a max of 2 because you have 1 upspin electron and 1 downspin electron, okay? So you have an upspin and a downspin, and then that orbital is full, All right, it can only take 2 electrons. Again, we'll talk more about this later. I do want to draw this out of what it actually looks like. But before I do that, I want to give you an analogy, okay? So a way to kind of wrap your head around this concept of what in the blank does this mean, shells, subshells, and orbitals. I kind of want you to think about like an apartment complex. Imagine I had an apartment building. All right, there we go. So here's my apartment building, okay? And you can kind of think about your electron configuration very much like an apartment building, okay? So your floors of your apartment building are gonna be your shells. So floor number 1 would be like shell 1, shell 2, shell 3, shell 4. Then you're gonna have within, you know, on each floor, you're gonna have different apartments. And your different apartments, your specific apartments are going to be your subshells. And then within each apartment, I'm gonna have a number of rooms within that apartment. And the number of rooms within each apartment is going to be like my orbitals, okay? So if you can kind of keep this kind of analogy in mind, hopefully that will help you just conceptualize what in the blank we are talking about when we're talking about electron configuration. I attempted to draw this out, okay? So we'll see if this helps, maybe, okay? So imagine I took my elevator up on my apartment complex to the 4th floor, okay? So boop, I'm now on the 4th floor. So this would be like my 4th shell. And when I get to my 4th shell, my 4th floor, there are 4 different apartments. I have the S apartment, the P apartment, the D apartment, and the F apartment, right? So I have these different subshells, these different apartments on that 4th floor, on that 4th shell. Okay, so if I went into the S apartment, then I can figure out how many rooms are in this S apartment. And this S apartment only has this one giant room. So here's S. I don't know if we can see that, right? So I walk down the hall, I go into the S apartment or the S subshell, and there's one room, there's one orbital in that apartment, okay? Then if I'm still on my 4th shell, okay? And then I walk over to my P apartment, okay? My P subshell. And when I walk in, I find, look at that, there's 3 rooms, 1, 2, 3. Okay, so there's 3 orbitals within that P shell. So now if I come down to my D subshell, right, my D apartment, and I walk inside, I now have 1, 2, 3, 4, 5 rooms, right? I have 5 orbitals. All right, so these are all apartments on the same 4th floor, but each apartment is designed differently. It has a different number of rooms, has a different number of orbitals, and it's shaped differently, okay? Last but not least, I have my F apartment or my F subshell. And this has 1, 2, 3, 4, 5, 6, 7 rooms, okay, 7 orbitals. All right, so hopefully this helps, right? So the floor of your apartment building is like your shell itself. And then each apartment would be like a subshell, okay, because each apartment's gonna be different. And then the number of rooms within that apartment is going to be like your orbitals, right? How many locations can you actually find electrons within this apartment, okay, within this subshell, right? Eek, okay? And just to point out, these always increase by odd numbers. So S orbital has 1, the next odd number is 3 for P, the next odd number is 5 for D, and then 7 for F. Okay, all right, now let's break it down on our periodic table. Okay, so our periodic table you can actually break down very, very easily to show kind of which electron subshell is where, okay? Now we all know our shells are just labeled here by our periods, right? So 1, 2, 3, 4, 5, 6, 7. This tells us our shells. All right, but now what the heck, where are the subshells, right? Where are these SPDFs? Super easy. So right here, okay, the line between your alkaline metals and your transition metals, boom, block this off. And right here, okay? And I'm including that blank space for a reason. Okay, because helium, beep, 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 is technically over here. Okay? Helium fits right there for its orbital. This is my s orbital. Okay, that's my s orbital. Then next, okay, is going to be over here. All right, where this kind of edge of boron is, right? Right where that stair step is. Don't include helium in this because helium is over here in S. Okay, so this section comes next, and these guys are going to be your p orbital. Okay, then I have this beautiful section of my transition metals. It's going to be my D. And then way down at the bottom, my inner transition metals, right? My lanthanides, my actinides. These guys are my F orbitals, okay? My F subshells. God, have I been saying orbitals? So S subshell, P subshell, D subshell, and F. Let's just write this out. S, P, D, and F. And I actually think you should label them. Okay, so your S subshell is going to start on shell 1. P is going to start on shell 2. D is going to start on shell 3. And F is going to start on shell 4. This will make sense in just a second, I promise. But if you could just remember S, P, D, F, 1, 2, 3, 4. Okay, so this tells me what shell these subshells actually begin on. So D subshells don't even start until shell number 3. So there are no D orbitals in shell 2 or shell 1, okay? And you can actually kind of see that, okay? Here's my D orbitals, right? Here's gonna be shell 1, here's shell 2. They don't fit. These D orbitals, nothing is in shell 1 and shell 2 for D, okay? Same with F, right? F doesn't fit into the first or second or third shell. All right. So if it helps, which I think it does, what I would do is for S, I would write a 1 right here to remind you that this is going to be 1S. We'll break it down in a second. So S starts with 1, P starts with 2. So I would put a 2 right here to remind me that P is going to start at 2. D starts at 3, kind of gets icky because there's no space in between here. So if you want, you can, put it right here on scandium. You can put it right above. Okay, there's not a lot of space necessarily right here, but just somehow remember that your D subshell starts on the 3rd shell, okay? And F, there's space here, so you could say it starts at 4. Let me actually try and draw this out. Okay, so if I have my shell 1, shell 2, shell 3, okay? So here's 3 shells worth on an atom, okay? In shell 1, okay, in shell 1, the only subshell that fits is an S, which is a spherical shape, okay? And I will use the same colors as this to keep everything simple, okay? So S is going to be purple, and here I am on shell 1. The only thing that fits is hydrogen and helium, right? In my S block here, okay? So I'm going to have on my first shell, I have this beautiful purple circle sphere, okay? Boom, and that's it. That's my shell 1 with my subshell, my S subshell, okay? And that's it. That's all that fits on shell 1. Then I go to shell 2. In shell 2, I have this S subshell as well. So I'm going to have this spherical, here we go, subshell, okay? So I have my S subshell, and I have my P subshell right here, right? Because it starts at my second shell. My P subshell starts on my second shell, right? P starts at 2. So I am going to have this dumbbell shaped orbital on my second shell. So I'm going to attempt to draw this. Okay, so I have this subshell of P within my second shell of my electron shell. Okay, so this is a P, right? Let's see if I have my ridiculous, apartment building. Oh, good. I flip-flopped these colors. Oh, how terrible of me. I apologize. Okay. But this is P, right? So your P subshell has 1, 2, 3 orbitals. Okay. Or you could remember in an orbital, 2 electrons will fit. And you can count across for your P subshell. Okay. Because 2 electrons fit in an orbital. So 1, 2 in my P subshell, that's 1 orbital. 1, 2, that's 2 orbitals. And then 1, 2, this will be 3 orbitals fitting within the P subshell. Okay, 1, 2, 3 orbitals. So I have 1, then I'm going to do 2, and then I'm going to do 3. So I have 3 P orbitals for my P subshell within my second electron shell. Good Lord, I know this is tricky, okay? And then that's it. Nothing else fits in my second shell. Then I go down to my third shell, okay? My third shell has S right here. Okay, so I have my S purple spherical electron shell. That's going to be there for my third shell. My S subshell fits in there. I do have a P orbital that fits in my third shell, right here. And there's 1, 2, 3 orbitals of P that fit in there. So try and draw it this way. 1, 2, 3 P orbitals make up my P subshell fitting in my third electron shell. Okay, and then D orbitals start on shell 3, right? The D subshell starts on shell 3. And you can count to see exactly how many orbitals you're going to have because 2 electrons fit in an orbital. So 1, 2, there's 1 orbital, 2 orbitals, 3 orbitals, 4 orbitals, 5 orbitals for D. Okay, this is going to be a horrible picture. And D is this like flower shape, okay? It's just gonna be crazy. So I have 1 orbital of D, 2 orbitals of D, 3 orbitals of D, 4 orbitals of D, and 1, 2, 3, 4, 5 orbitals of D. Okay, so I've got now 5 orbitals of my D subshell fitting in my third electron shell. Okay, I hope that didn't confuse you more. I hope that's at least a visual way to see it. All right, now let's actually do some electron configurations. Okay, there you go. Okay, so we're going to start with hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay, so we'll do these first, okay? And we're gonna write out the electron configuration for these elements, okay? And then we'll get even more complex. So hydrogen, and you just kind of count on your periodic table. So hydrogen's in my first shell. So 1, he's on the first shell. Then what subshell is hydrogen in? He's in the S subshell, okay? So 1s, and then how many electrons fit in that 1s subshell? 1, because I only count across 1 to get to him. So 1s with a little exponent of 1 for hydrogen. Helium is on my first shell, so 1. The S subshell. And how many electrons fit in that S? 1, 2. So he's going to be 1s with an exponent of 2. Okay, that superscript tells me how many electrons are fitting in there. Then I have lithium. Well, lithium has just like your Bohr models, you're showing the inside shells are filled first. So lithium has that first shell filled. So he has 1s2 filled up. And now lithium's on the second shell, so 2. He's on the second shell. He's in the S subshell. And in the 2s subshell, is on the first column, so 2s1. Okay, this is the electron configuration for lithium. Beryllium would again be 1s2, because that first shell, S subshell, has 2 electrons filling it. And then beryllium is here on 2s, 1, 2. Then this finally gets interesting, okay? Boron is going to have 1s2, 2s2 is also filled, and then I go across here finally to a different type of subshell. This starts on shell number 2, so this is going to be 2p. Now I'm in my p subshell, and boron has 1 electron there to get there. All right, so 1 electron in my p subshell to get to boron. All right, carbon is going to be, again, 1s2, 2s2, and I'm on 2p, 1, 2 to get to carbon. Okay, nitrogen, 1s2, that's filled up, then 2s2, then 2p, 1, 2, 3 to get to nitrogen. Oxygen, 1s2, 2s2, 2p, 1, 2, 3, 4 to get to oxygen. Let's do a little bit trickier examples. Magnesium and chlorine. Okay, so magnesium's here. So I'm going to have 1s2 filled up. My 2s is filled up, so 2s, oh, s2, 2s2, right? My 2p is all the way filled up, so 2p, 1, 2, 3, 4, 5, 6. And then magnesium's here on my 3s, my third shell, with my S subshell and 1, 2 across to get there. Okay, so 3s2. Chlorine, 1s2, 2s2, 2p6, 3s2, and then I'm now in my third shell for my p subshell. To get to chlorine, I need to go 3p, 1, 2, 3, 4, 5. Okay, 3p5. So far, first, second, and third shell are pretty good. Then you get to your fourth shell and you are screwed. Okay, it gets confusing. Starting on your fourth shell. Let's do calcium, and then we'll do scandium, and then we'll do iron. So calcium, again, I fill up 1s2, 2s2, 2p6, 3s2, 3p6, and then I have 4s, 1, 2. Okay, actually, there is an abbreviated way, so you can just put in brackets. Let me teach you this now. You can put in brackets the noble gas directly before it. So calcium, the noble gas that's directly before calcium. So I'm on period number 4, right? I'm on shell number 4. So what noble gas do I have on shell number 3? Argon. Ar. Okay, so I can put in brackets argon to show, all right, I have this full electron configuration up until argon. Oops, that's cut off. Perfect. Okay, up until argon, and then I'm going to continue on. That way you don't have to write these out for days. Okay, so I filled up all the way to 3p6. Then I'm on my fourth shell, S subshell, with 1, 2 electrons there, okay, for calcium. Then scandium, okay, same thing. Argon's going to be all the way filled out. I have this 4s2, and now I'm finally in my d orbital. But you'll notice right here, d starts at 3. So even though like scandium is on the 4th period, the electrons that go in the d shell don't actually fit on that 4th shell. They fit 1 shell below. So those d electrons are fitting into the 3rd shell. Seems counterintuitive, but just if you write out 1, 2, 3, 4, you shouldn't screw up, and you should just be able to kind of follow the numbers. All right, so this should be 3 right here. D, you're in your D subshell, and then scandium is 1 into your D shell, D subshell. Iron, what again? You have all the way up to argon, then you have 4s2, iron's right here. So you're in your 3D shell. Okay, your 3D subshell, 3D, 1, 2, 3, 4, 5, 6. Let's just pick something within the F. That way you can see how that looks. And then we'll be done with this horrible thing, okay? Uranium, okay? One of the very bottom. And I will write out the whole thing, okay? So I'm trying to get here on uranium. All right, so my 1s is filled up. So 1s2. Then 2s2 is filled up. Then 2p6. Then 3s2. 3p6. And then 4s2. Okay, and then this D block starts at 3, so 4s2, then 3d10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, but now here I'm going to be back at 4 for my P subshell, right? This is 2, this is 3, this is 4. So 4p, 1, 2, 3, 4, 5, 6. If it helps you, you can literally go 2, 3, 4, 5, 6. Okay, write it all out for yourself. Why not? Take the time. 1, 2, 3. I mean, I guess you don't need to write out these ones for S because they're written right there for the periods. For D, write it out. 3, 4, 5, and 6. And F is going to be 4 and 5. So I just filled up 4p6. Then I get kicked down to 5s2. Right, and now I'm at 4d10. And then 5p6. Now I'm at 6s2. And now, remember, your lanthanides and actinides kind of break out of here. So I'm going to start my F orbital here, but F orbit starts at 4. So I go from 6s2 to 4f, and then count across. It's 14. You can trust me or you can count. 1, 2, 3, 4, 5, 6, 7, 8, 14. Okay. So I finished up 4f14. Then I'm up here, 5d10. And then 6p6. I know this is terrible. Okay. Finally, you're at 7s2. And down here at 5f, and I need to get to uranium. 1, 2, 3, 4. Okay, death. Absolutely, this would be the longest, hardest, trickiest type you would have. Okay, you will see this written out as like one long thing, right? You won't see it broken up. I just wanted to do that. That way you can kind of follow along with the periodic table. But the way this would actually be written out, I'll speed this up. Okay, the way it would actually be written out is in one giant long line, okay? All right, so that's electron configuration. It seems tricky and terrible. I guess one last type of question. You could have a question like this on a test, okay? So you are given this electron configuration, and then it says, what element is this? I would have to figure out 1s2, 2s2, 2p6, 3s2, 3p3. What element is this? Okay, well, I don't really care about all the stuff that's already filled up. So I care about it's on the third shell, right? 3s2, 3p3. All right, so 3s2 is filled up, right? This guy's filled up. And then I'm at 3p, so I'm on my third shell, my p subshell, and I go across 1, 2, 3. Boom, this is phosphorus. All right. I know this is a lot. I hope that helps you break down electron configuration. Please Google, watch more videos about it. This is by far the trickiest type of thing with atomic structure. So that's it though. That's it. Chapter 3 is over. Yay. All right. Good luck.